All right, so we're starting by taking a look at these two problems, solving square root equations. So for that first one, square root of x minus 4 equals 5, make sure that when you wrote it down that you clearly showed that only the x is in the square root. The minus 4 is not under the square root symbol, which means that the very first thing I want to do then is get rid of that 4, because my first goal is to get the square root by itself. So first thing you want to do is go ahead and add 4 to both sides of your equation. Now at this point we have the square root of x equals 9. I now need to get rid of the square root. What undoes a square root? Squaring. You're going to square both sides of the. And so because a square root is like the second root, that's basically what's going on behind the scenes on those, we raise it to the power of 2. Now the idea of doing that is that on the left side here where we do the square root of x squared, what we're doing then is we're actually canceling out the square root part by squaring it. So on the left we just have an x left behind. On the right side we actually do the 9 squared, which equals 81. Notice there's no plus or minus here. That's the part that eventually could start tripping you up on these, so we want to make it clear here. You include the plus or minus when you introduce the square root. Here the square root was given to us at the start. What we introduced was the square. That does not require the plus or minus. So you only have to worry about plus or minus when you square root both sides. All right, so we got x equals 81. That means we're done. That's it. That's our final answer. X equals 81. And we can even prove that that's the right answer, because if you take that 81 and plug it back in for x up here, square root of 81 is 9. 9 minus 4 is 5. It works. Okay, let's go to the next one over then. Again, the first thing we want to do is we want to get the square root part by itself. In this case, then, that means we got to get rid of this plus 3, because notice the plus 3 is outside of the square root. So in order to do so, go ahead and subtract 3 from both sides. Okay, once we've done that, then of course we're getting rid of the square root symbol. In order to get rid of the square root, we need to square both sides again. Now when we square both sides, whatever was inside of the square root, that stays the same. So we're just going to end up, after we square both sides, with x plus 5 equals the 16. So notice the x plus 5 part, it didn't change, because all the squaring does is cancel out the square root. All right, and then one last easy step to get the x by itself, of course, because we still didn't get our solution. So move that 5 to the other side. So subtract 5, you got x equals 11. So it works. And yes, we can even plug that back in and check it here. So 11 plus 5 is 16. The square root of 16 is 4. And 4 plus the 3 would be 7. So yes, it all works. All right, now for these, we approach them the same way. Step 1, get the square root by itself. So then on this first one, then that means I got to get this by itself, which means moving that plus 1 out of that left side. So first step, subtract 1 from both sides. So we got the square root of 3x equals 6. And again, you get rid of the square root by squaring both. Now when we square both sides, remember it leaves whatever was inside of the radical exactly as it was. So notice that's a 3x over here. It's not a 9x, which can be tempting, because that 3 was inside of the square root. Really, we're squaring the square root of 3. All right, so then if we have 3x equals 36, I want to get x by itself. So in order to get rid of the 3 times x, I divide by 3. And so you should end up with x equals 12. And again, you can plug that back in to make sure that it gives you the right thing. So like 3 times 12 is 36. The square root of 36 is 6. And 6 plus 1, yes, equals 7. All right, on the next one. For that one, we start by squaring both sides. And then I move the 2 over. We get x equals 79. If I take that 79 and plug it in, well, 79 plus 2 is 81. The square root of 81 is 9. Notice, that means it doesn't work, because when I plug that back in, I end up with 9, but it's supposed to equal a negative 9 up here, not 9. If I come out and it says that when I plug this in, 9 equals negative 9, that's not true. That means there's actually no solution for that. And logically, that can kind of make sense, because anytime you take the square root of a number, you get a positive, right? You cannot take the square root of a negative. That would give us an imaginary number, and we're just dealing with real solutions here. And so the square root of no number equals negative 9. A square root can't equal a negative. And so anytime you're working through one of these and you get the square root by itself, notice you got to get the square root by itself first. But if the square root is by itself and that's equal to a negative, you can know right there that there's going to be no solution. And so that's what we'd actually say for this one, is no solution. So for that first one, again, I got to start by getting the square root by itself. That means I got to get rid of the 3. Since it's 3 times the square root, that means I want to go ahead and divide both sides by 3. And then from there, hopefully fairly straightforward, square both sides to get rid of the square root, then move that 1 to the other side. So we end up with x equals 26. And again, 26 minus 1 is 25. The square root of 25 is 5. 3 times 5, yes, is 15. It does work. All right, for the next one, same basic idea. I got to get the square root by itself first. Now, whenever there's multiplication and addition or subtraction going on, we want to get rid of the addition or subtraction first. It's going to make your life a little bit easier, keeps you from having to remember some little details along the way. So I'm going to go ahead and add that 1 to both sides. Then we got to get rid of the 1/2. And this is where there could be a potential hiccup for you here, so we got to pay close attention on it. If I have some number multiplied out front of a square root, I can divide by that number. And so if I want to get rid of this 1/2, I can go ahead and divide both sides by that 1/2. But remembering how to divide it by 1/2 is sometimes the tricky part for us, because we have to remember the rules for how do we actually divide by a fraction. So if you're a little rusty on this, here's your quick little review. I'm going to be doing 4 divided by 1/2. Well, first of all, if we're going to be dealing with a fraction, let's go ahead and make them both into fractions. So it's like 4 over 1 divided by 1/2. And then to divide by a fraction, this is the one where we multiply by the reciprocal. Or in other words, flip the second fraction and change the division to multiplication. It's always the second fraction that flips. So notice, by doing that, we can see that dividing by 1/2 is exactly the same as multiplying by 2. Which means also, if you thought of it this way, this would also be fine. If up here, instead of writing divide by 1/2, if you'd written times 2 on both sides, that would also work. It'll do the exact same thing. Because in order to divide by 1/2, we multiply 4 by 2. So it just equals 8. So I now have the square root of x plus 8 equals 8. Now from here, same thing that we've been doing, right? I want to get rid of the square root, so that means squaring both sides. And then subtract the 8 from both sides to get our final answer of x equals 56. And yes, if you plug that back in for x up here, you will get the same answer. We will get the correct thing there. Right, now both of these problems are a little bit different from the stuff we've been doing so far. The first one, notice this one is a cube root, different from a square root. It's a cube root is saying what number times itself 3 times would equal this. So we got to start though by still getting rid of the radical. The same thing that we did before we got to do here. Get rid of the radical. Radical, by the way, just another word for root, means the same thing. They're synonymous. So I want to get rid of the radical symbol here, the cube root symbol. Well, if I square a square root, what do you suppose I'm going to do to a cube root? Cube it. We're going to raise both sides to the power of 3. And that's going to work on any of these roots that you might see. If it was a 4th root, we'd raise both sides to the power of 4. If it was a 5th root, we'd raise both sides to the power of 5, etc. Right, now, just like with the square root, when we cube both sides, it gets rid of that radical. So on the left side, I'm just left with whatever was inside, the 1 minus x. And then on the right side, it equals 8, because 2 cubed, that is 2 times 2 times 2, equals 8. So solving it from here, there are a couple potential pitfalls depending on how you look at it. So the first thing I normally want to do is get the x by itself over here, so I'll normally get rid of any addition or subtraction. And so most of you, if you're like me, are thinking, let's move the 1 first. But if I want to get the 1 out of this side, I'm not going to add it, which is the temptation, because we see subtraction here, and you might be thinking, well, it's got to be addition then, because we're undoing subtraction. But notice the 1, it's a positive 1. If I added 1 to that, there would be a 2 there. I wouldn't be rid of it. I want it to become a 0. And so I'm actually going to subtract 1 from both sides. Now what happens then to that minus that was in front of the x? Well, it stays in front of the x. It's now a negative x equals 7. Now anytime you have that negative sitting out front of your variable, or you'll even see the negative sitting out front of square roots and stuff, if you want to get rid of that negative, think of it as negative 1 times x. Because that's what negative x really means, negative 1 times x. And so to get rid of it, I would divide both sides by negative 1. Now, technically speaking, you could also multiply both sides by negative 1 because it's 1. Doesn't change whether you multiply or divide. But I like to stay consistent with the operation, so I divide by negative 1. And so we end up with the final answer here of x equals negative 7. And yes, if we plug that in, it will still work, because 1 minus a negative 7, that's like 1 plus 7, so that's 8. And the cube root of 8 is 2. So yes, that does work. That is going to give us the correct solution. All right, now on to the right side. Here we have the square root of x plus 6. Okay, fine, that's fairly typical. Minus x equals 0. And that's the new variation on the second one, is that our x is both inside the radical and outside the radical. And that's going to create a new wrinkle, as you're going to see here. But our basic process, at least at the start, is identical. First thing we want to do is get the square root by itself. So we add x to both sides. And we try to get the square root by itself because we're going to get rid of the square root. We are going to square both sides of the equation. Now when we do that, on the left side we just have our x plus 6 left behind. Whatever was inside the radical stays. But on the right side we're squaring x, which just leaves us with x squared. Now notice what we have here. I have x plus 6 equals x squared. This problem is a great example about how the stuff that we did first semester is going to keep coming back. Because in order to solve this, you have to use a skill that we learned during first semester. Because we're solving a quadratic here. In order to solve a quadratic, remember we had 3 main methods that we used. We had the square root principle, we had factoring, and we had quadratic formula. Okay, can we use square root principle in this case? Well, in order to use square root principle, we had to have x squared and a number only. There couldn't be another x hanging out there. And so for that reason, no, we cannot use the square root principle here. All right, option 2 is factoring, option 3 is quadratic formula. For both of those methods, we always had to set up our quadratic the same way. Remember, we had always set our quadratic equal to what? 0. And so that's going to be the next thing we have to do in this case then. We got to set this thing equal to 0. And because I like to keep my x squared term positive, I'm going to move everything to the right side. All right, now that we've gotten to here, now we can decide if we're going to use factoring or quadratic formula. And remember, if you can factor it, do so, because it's going to be a lot easier doing it that way than having to go through the whole quadratic formula. So, is this one factorable? In other words, are there two numbers that add to negative 1 and multiply to negative 6? Yes, there is. We end up getting a negative 3 and a positive 2 there as our factored form. So x minus 3 times x plus 2. Now, of course, that's just our factored form. That's what we use now to get our solutions. Remember, you set each of these parentheses equal to 0. So you do x minus 3 equals 0, so that's going to give us 3. And the x plus 2 equals 0, that gives us an answer of negative 2. So, a little bit more involved, right? We actually ended up with a quadratic, and then I had to use my methods that I know for solving a quadratic. The fun part is, though, that we're still not done with this problem, as you're going to see. This is where we now have to deal with the fact that we started with an x both inside and outside of the radical. Whenever that happens, we have to check our solutions. Because, remember earlier we saw that our square root can't ever equal a negative number? Well, notice like for instance on this line here, if it equals x, it could be set equal to a negative number depending on what x is. And so we're actually going to have to check our solutions here. The basic rule is that when x is both inside and outside of the radical, we need to check the solutions. So that's what you're looking for. If it's inside and outside, we check our solutions. Now, when I say check our solutions, I mean that we are going to plug each number in individually back into the original equation, and we're just going to see what that equals. And so notice this first example, we're going to be plugging in the 3 and seeing what that gives us. And so you notice wherever there was an x, there's now a 3 over here. Now when I plug it in there, I am just doing arithmetic. I am not doing algebra, I'm doing arithmetic. In other words, I'm just seeing what it equals. I'm not going to move stuff side to side. So I do order of operations, the 3 plus 6 first, the stuff inside the radical first. Then I'm going to do the square root of 9. Okay, that's going to be 3. So now I have 3 minus 3. And then I do the 3 minus the 3, which gives me 0. And so 0 equals 0 is the statement we end up with. Now that obviously is true. 0 does 0. And so that means that 3 actually is a solution here. Now it's possible that only one of them is a solution. It's also possible that both are solutions, and it's possible that neither is a solution when you do one of these. So you actually have to check that other one. The first one doesn't tell me anything about the other one. All right, so next up we're going to plug in the negative 2. So notice the negative 2 is in for x in both places where the x was. And again, we're just evaluating here. We're not moving stuff side to side in the equation. If you do that, you might actually create the false positive situation that we're trying to check for. All right, so order of operations, do the stuff inside the square root first, then actually take the square root, and then we do the addition that's left behind, the 2 plus the 2. Advanced math there, right? And so we end up with 4 equals 0, which obviously is not true. 4 does not equal 0. And so what that tells us then is that over here with our solutions, that x actually isn't going to equal both 3 and negative 2. X only equals 3. And so there's actually only one solution to this. The other one was like this false positive. It's this solution that looked like a solution, but it really wasn't. It's like extra, right? We did all this work and we got this extra stuff. Well, there's a term for that. Unsurprisingly for math, we got to have a new vocabulary piece for such a thing, right? And so this is going to be the last thing you're going to be writing down today. This goes into your note. Those extra solutions are called extraneous solutions. And they're numbers that look like they're solutions, but when we check them, they aren't really.